Page 10 of functions. Draw a sign diagram for, and they give us many functions here, okay? So basically, when you draw a sign diagram, and we've done these before, we draw a number line, and the first thing we mark are the zeros. Now for the zeros for A, we have a 0 at -4, we have a 0 at +2, and then we have unknown signs between the two and to the left and to the right. The easiest way to figure out the signs here is to take a number between -4 and 2. The easiest one would be 0. We put it in here. We get 0 plus 4 times 0 minus 2. We have a positive number times a negative number. We don't need to do the calculation, although it would be -8, right? But all we don't want to know is if it's a negative number. If we have a positive number times a negative number, it's a negative number, right? Now, if we want to test this region here, we're just going to test a really big number because it makes it easier. A really big number plus 4, a really big number minus 2, both of them are really big positive numbers. We multiply them together and we get a positive number. The same thing happens when we plug in a really big negative number. A really big negative number like a -100, this will give you -100 plus 4, huge negative number. -100 minus 2, also a huge negative number. I don't even need to figure out that these values are like -96 and -102. It doesn't matter. They're both negative, right? Two negative numbers multiplied times each other is a positive number. So, okay, so that would be 2a. Why do I only try one number in each of these regions? Why do I only do 0? Why don't I do -3? Why don't I do 1? Well, I could do all those, and I would find that all those values would be negative, okay? The reason why that I don't find a mixture of positive and negative numbers between the two 0 points is the definition of a 0 point is a transition between a negative region and a positive region, right? So if we know that there are no transition points between -4 and 2, we know that all the points between -4 and 2 are going to be all positive or all negative because we know there's no other transition points there, right? So we know these are all negative just by figuring out that one of the points is negative. We know all these points are positive just by figuring out if one of the points is positive, okay? And when I say one of the points is positive, I mean the y value of that x coordinate, okay? Let's do a few more. So we'll do B. B has two 0 points. The two 0 points for B are 0 and 3, right? So I'm going to draw the number line for that, 0 and 3. Those are 0 points. And now I'm going to test a number between 0 and 3, like 1. That's an easy one. I'm going to put 1 in for x. So I get 1 times 1 minus 3. That's 1 times -2. That's a negative number. So in between 0 and 3, it should be negative. What about a big positive number? A big positive number would be like 100. So 100 times 100 minus 3 is a big positive number also, positive. If I put a big negative number here, like -100, it's going to give me -100 times -103. Two big negative numbers that multiplied together gives me a positive number. I bet you're getting the hang of this now. What about D? So D, the 0 points are going to be -1. If I put -1 in there, it's going to be -1 plus 1, and that'll make it 0. 0 multiplied times anything here is going to be 0, so that's definitely a 0 point, right? The other 0 point would be +3 there, okay? Now I'm going to draw the number line for D. And the 0 points I'm going to mark as -1 and 3. I'm going to mark them zeros. And then I'm going to try a number between -1 and 3. 0 is probably the easiest, so I put 0 in here, I put 0 in here, I get +1 times -3. That's a negative number. But I also need to multiply that negative number I get here times this external negative. That's going to be a positive number, so in the end it's going to be a positive, right? And then I can also try a really big number to find out what this region would be, like +100. It's going to give me like about 100 times about 100. Two positive numbers times each other are going to be a positive number, and then I find the negative of that number, so it's going to be negative. Finally, I put in a big negative number, like a -100, so I'm going to get like -100 plus 1, which is about -100. Doesn't really change that much. I do -100 minus 3. That's still very close to -100, right? I multiply the -100 times -100. I get a positive number, and then I take the negative of that, and then again, negative here. you'll notice the patterns I'm getting here. Positive, negative, positive, negative, positive, negative, and positive, negative, positive. You see that there's like a pattern where it alternates between positive and negative, and most of the time that's going to be true. We're going to see a few cases where it's not, okay? And but in most cases, that's what you're going to see. So if you get that pattern, then you can kind of feel good that things are working out. Let's do E. So E has 2 0 points also. This is a little bit more tricky. The 0 point here is going to be 3, of course, but the 0 point here, maybe you might have trouble figuring that out. If you have trouble figuring it out, what you do is you set it up. You say 2x minus 1, which is the whole thing, and you say it's equal to 0. Now let's use algebra and figure it out. So I'm going to add 1 to both sides. I'll get 2x equals 1. Divide 2 both sides. It's going to get me x equals 1/2. So if you don't see this right away, that x is 1/2, go ahead and do this algebra, okay? So the 2 0 points are 1/2 and 3. I'm going to put those on the number line here. One of them is 1/2, and one of them is 3. Those are both 0 points, so I'm going to make them zeros. The book actually, instead of marking them 0, it just puts a line there, but I prefer the 0 notation. It's a little bit less vague. The book uses this notation probably because the 0 notation it uses to mark the origin. But you can use either one. So between 1/2 and 3, a nice convenient round number would be 1, right? So let's try 1. We're going to put 1 in here and 1 in here. That will give us 2 minus 1, which is 1, 3 minus 1, which is 2. 1 times positive 1 times positive 2 is a positive number, so positive number, right? And we suspect that if the middle one is positive, the left and the right one are going to be negative, but we're going to make sure. We're going to put positive 100 in there. We're going to get like a positive 200 times positive 100. Two numbers times each other, they're both positive. And hey, wait a second, that would be positive? Oh no, wait a second. I know that something's wrong because I'm supposed to get negative, right? Now I'm going to check my work here. If I put 100 in this one and 100 in this one, it's going to give me 200 times 3 minus 100, so it's actually 200 times negative 100, which is going to be a negative big number. So yeah, it indeed gives me negative here. Now the same thing's going to happen when I take negative 100 and put it in here. I get a big negative number in this one. I get a big positive number in this one because it's negative minus 100, or minus negative 100. And that'll multiply together. That will also give me a negative number. So I'm right in that it's negative, positive, negative. Okay, let's move on to G. Oh, G. So to find the zeros of x squared minus 9, there's a couple ways to do that. One is you could factor it, and if you factor it, you'll get x plus 3, x minus 3. And then we can see that the zeros in this case are going to be negative 3 or positive 3, right? The other way you could do it is you could take the x squared minus 9 and you could set it equal to 0, and then you could solve for the x squared. You get x squared equals positive 9, and when you take the square root of both sides, you're going to get x equals plus or minus the square root of 9, which is 3. It could be x equals positive 3 or x equals minus 3. You see that we got the exact same thing we did right there, right? Okay, so let's make the sign diagram for that. We're going to have on our number line, we're going to have negative 3 and positive 3. To test a number in between, let's check 0. If we put 0 in there, we'll get 0 squared minus 9, which is a negative number. If we put a big positive number, we're going to get a huge positive number minus 9, which is positive. If we put a negative number, a big negative number, we're just going to get two huge negative numbers times each other. It's going to be a positive number minus 9, so it's a positive also. Okay? So that's G. Let's do H. H, you can do similarly. You can factor it into 2 minus x, 2 plus x, and that'll give you the two zeros as positive 2 and minus 2. The other way you could do it is the same way we just did the other one. We do 4 minus x squared equals 0. Then we subtract x squared to the other side. We get 4 equals x squared. So x is going to be equal to positive 2 or negative 2, right? So either way you get the same thing. And then we're going to draw our number line for h. It's going to be a number line with -2 and +2. And we're going to check the 0 point here in the middle. And when we put 0 in there, we're going to get 2 minus 0 times 2 plus 0. It's 2 times 2, which is a positive number, 4, right? And so probably these are going to be negative and negative, right? So let's test to make sure. We're going to put a big positive number like 100 in there. We're going to get negative 100 times positive 100. It's going to be a negative number. That's right. Then we put negative 100 in there, and we get 2 minus a negative number, which is going to be 2 plus 100. And then we're going to do the same thing on this one. We're going to get 2 minus 100. We're going to get about negative 100. So we're going to get negative 100 times a positive 100. It's going to be a negative number again. So that worked out also. Okay. Let's go over to J. So J has a quadratic, and it's not factored. That wasn't very nice of them, was it? So let's factor it. It's probably going to be something 1 and 2, maybe like 2 negatives. Hey, that works. Negative 1 times negative 2 gives us positive 2. Negative 1 times x gives us negative 1x. Negative 2 times x gives us negative 2x. We add those two together, we get negative 3x. It worked out. Good. Okay, so our zeros in this case are going to be x equals 1 and x equals 2, right? So let's write that out here for J. We're going to have x equals 1 and x equals 2. And we are going to try some numbers in between. Let's try a big positive number like 100. So we're going to get 100 times 100. That's a big positive number. Let's try a big negative number like negative 100. So we're going to get negative 101 times negative 102. Two big negative numbers multiplied times each other give us a positive number. The middle must be negative, right? Because that's the pattern we've been having. Okay. So just to make sure, we could try 1.5. If we try 1.5, we'll get 1.5 minus 1 is 0.5, positive 0.5. We do 1.5 minus 2, it'll give us negative 0.5. We have positive 0.5 times negative 0.5. That'll give us a negative number. So indeed, in the middle between 1 and 2, we're going to have a negative number. Okay, finally, let's go over to K. K, that's different than what we usually have, isn't it? Now, we could factor this out. We could, if you have 2 minus 8x squared, it might give you the urge to factor out the 2. You'll get 1 minus 4x squared. Then you could factor this into 1 minus 2x and 1 plus 2x. Of course, the other way, and that'll give you the zeros of x equals 1/2 and x equals negative 1/2. But we could find that also just by setting 2 minus 8x squared to 0. And then we'll subtract 8x squared to the other side. We'll get 1/4 equals x squared. So x is equal to plus or minus 1/2. Okay, so either way, you're going to get the same thing, right? So let's make a number line now for K. We're going to have negative 1/2 and positive 1/2. And if we put in a really big positive number, we're going to put it into there, and we're going to see that we get a negative number times a positive number, which is negative. If we put in a really big negative number, we see we're going to get a positive number times a negative number. It's also going to give us a negative number. And if we put a number right in between, like 0, it's going to give us a 1 times 1, which is a positive number, so the middle is going to be positive. Okay? All right. M. M has also an unfactored quadratic, and this quadratic doesn't look like it's too easily factored, so I have the urge to maybe use the quadratic formula. So it looks like, and the tricky thing here is that they kind of reverse the order. The A value is here, the C value is here, and the B value is here. So be careful of that when you're doing the quadratic formula for M. Let's see, I'm going to put x equals negative b, which is going to be positive 16, plus or minus the square root. 16 squared, that's a huge number. I don't need to put negative 16 squared because negative 16 in parentheses squared is just the same as positive 16 squared. Minus 4ac, which is going to be negative 6 times 6. All over 2 times a, which is negative 12. That looks awful, doesn't it? Okay, and I'm going to use the calculator to complete this. As usually happens with a book problem, if you do 16 squared minus 4 times negative 6 times 6, you're going to end up with 400, which happens to be a nice even, round square root. So it's going to be a square, the square root is going to be 20. So we get 16 plus 20 divided by negative 12. Or we get 16 minus 20 divided by negative 12. So both of those are nice numbers. Like that one's going to be negative 3, and this other one is going to be negative 4 divided by negative 12, which is positive 1/3. Okay, so those are the 0 points for M. And that was a lot of work, wasn't it? Next time, you can use poly-SMLT. If I plug 0 in, that will give us the value for the interval inside. So that would be, it would be a positive value. If we put 0 in for that and we put 0 in for that, the middle value, it's going to be a value of positive 6, right? If we put in a really big positive number, we're going to get a negative value here, right? If we put a really big negative number, we're going to get a also a negative number, okay? It might not be really clear, but like this number is going to be overpoweringly big the bigger the number you put, because an x squared term is always bigger than the x term. But if you're not sure, go ahead and use a calculator, put like negative 100 in there, see what you get, okay? Did you notice that since we don't have this factored out, it makes it harder to plug in the numbers, but we can still use the standard form equation to do that. All right, and then finally we're going to do n. So for n, again, we have an unfactored equation. So to find the zeros, we can use quadratic formula, but I've had enough of that, so I'm going to use the calculator. Okay, so I'm going to click enter on the poly-SMLT app. I'm going to do poly root finder. I'm going to put second degree equation. For a2, I'm going to put negative 2 because that's the a term. A1 is going to be 9, and finally C is going to be 5, or A0 is going to be 5. I'm going to solve it, and there are my roots, 5 and negative 1/2. That was a lot easier than factoring. 5 and negative 1/2. Okay, but it was possible to do this by factoring, right? And I'm going to put n, and then the two 0 values are negative 1/2 and 5. I can put in 0 here, and I'm going to get 0 plus 0 plus 5 is positive. So probably these are going to be negative and negative, right? Because that's the pattern we've been seeing with quadratics. If we put in a big positive number, we can see that we're going to get a negative number out. If we put in a big negative number, we're also going to get a negative number out. You can confirm by putting in negative 100 and positive 100 with your calculator, okay? And that's it for the top part. Moving down here to number 3, remember how I was telling you where there's some cases where it's nice and alternating, like negative, positive, negative, and other cases it's not. Well, we're going to see some cases where it's not. So like for example, in 3a, the zeros are, there's going to be a repeated root, right? It's going to be negative 2 and negative 2. And there's a strange thing that happens with repeated roots. When you have repeated roots, you're not going to get that nice little pattern, and one of the reasons why is because you only have one root. So if you look at this, you're going to test a big negative number, and you're going to get negative number squared, which is positive. You test a big positive number, and you get positive number squared, and you get positive. So you can see that in this case, you don't get a plus minus plus or negative plus negative pattern. And the whole reason why is, if you look at the quadratic that goes along with this one, you know that it crosses the x-axis at negative 2, it touches it at negative 2, and it goes up, right, because the a value is positive. And look, it goes from being positive to being positive, and it never becomes negative because it only touches at one point. So it makes perfect sense that in this case there's only one 0 point, and it's positive on both sides of it, right? Okay, what about b? For b, the x-intercept is going to be positive 3, and again, we can suspect that it's going to be positive on both sides because the a value is positive. But we can check by putting like 100. If we have 100 minus 3, that's a positive number squared. It's positive. Same thing with the negative number. Okay. What about d? D, the root appears to be a double root at x equals 4, right? And so, and in this case, the a value is negative, so we can suspect that both sides are going to be negative here. But we can check. We can put in like positive 100, and we're going to get 100 minus 4, which is 96. Positive number, big positive number squared is a big positive number, and then we take the negative of that, and then we'll get a negative number. Same thing happens on the negative side, right? Okay, so D looks like that. E, so E is not factored for us, but this is an easy one to factor. It's x minus 1 times x minus 1, or x minus 1 squared. So we know that the number line is going to have just one root marked, which is 1. And both the left side and the right side are going to be positive. The reason why we know that is because the a value is positive, but we could also do it by plugging in a number like positive 100. We get big number times big number, both positive, equals positive. We put in a negative 100, we're going to get negative big number times negative big number, and we're going to get positive also. Okay? What about G? This is also not factored. It's probably not too hard to factor. I think it's going to give us something like 2x minus 1 times 2x minus 1. Yeah, that seems to work out. So the two roots are going to be positive 1/2 and positive 1/2. It's a double root, of course, again. That's one predictable thing about the book. They're going to group the problems like this, so it makes it much easier than the real exam, right? So for G, we're going to have one root like that, and then if we put in a big positive number, we're going to get positive times positive, which is positive. If we put in a big negative number, we're going to get negative times negative, which is also positive. So that's the way the sign diagram for G looks. What about H? That looks kind of scary, but if we factor out a negative, it's probably not so bad. Now, if we look at that, now that doesn't look so bad, right? We could factor that into x plus 3, right? Yeah, that works. So our roots are negative 3 and negative 3, and the a value is negative, right? So we'll mark negative 3 here. Probably it's going to be negative on both sides, but we can confirm by putting in like positive 100, and we'll get a 100 something times 100 something, which gives us a big positive number, and then we take the negative of that, and we'll get a negative. Same thing happens on the negative side. So that was the sign diagram for H. Okay, finally number 4. Draw sign diagrams for these functions. Now these functions are not quadratics anymore, okay? And these appear to have asymptotes also. So let's see, we have, in A, we have an asymptote at x equals 1, right? So first thing I'm going to do is draw an asymptote at x equals 1. On the top, I can see I have a 0 at negative 2. When I put x equals negative 2 in there, the whole thing turns 0, so I can put negative 2, 0. And then I need to test points in between each of these. So if I put in a big negative number, I'm going to get a big negative number divided by a big negative number, which is a positive number. If I put a big positive number, I'm going to get a big positive number divided by a big positive number, which is a positive number. And then finally, if I put in 0, which is in between these two, I'm going to get 2 divided by negative 1, which is a negative number. Okay, and you notice that it also follows the pattern of positive, negative, positive, which sometimes also works for hyperbolas. Okay, so that kind of makes us feel warm and cozy when we see that work out like that. But it's not necessarily always going to be like that. So here we see that the denominator, we can find the asymptote by seeing that x equals negative 3 is a very bad value to have, because x equals negative 3 is going to give us negative 3 plus 3, which is going to make the bottom 0. So the 0 is an asymptote, right? And the top is going to be 0 when x equals, I'm sorry, that's should be -3. -3 asymptote. And the top is going to be 0 when x equals 0. So that's our 0 value. If we put in a big positive number, we're going to get positive divided by positive, which is positive. If we put in a big negative number, down here, we're going to get negative divided by negative, which is also positive. If we put in a number like -2, then we'll get -2 divided by 1, which is a negative number. And again, we get positive, negative, positive, alternating here. Makes us think we got the right answer. Okay, E. Here the asymptote is at x equals 2, right? And the 0 is at x equals 0, right? So we're going to graph that. We're going to have 2 and 0 here. The asymptote is 2, and the 0 value is 0. Big positive number here is going to give us positive divided by positive. Big negative number here is going to give us negative divided by negative, also positive. And then if we put in a number in between like 1, we're going to get 3 divided by -1, which is negative. Okay, so that was the result for E. F, we're going to have a asymptote at x equals 3, right? Asymptote. And then we're going to see a 0 in the numerator when x equals 0, so that would be a 0. If we put in a big positive number, we're going to get negative number on top divided by negative number on the bottom, which is positive. If we put in a big negative number, we're going to get a positive number on top divided by a positive number, which is positive. And if we put in a number between 0 and 3 like 1, we're going to get -8 divided by 2, which is a negative number. Almost done. Ooh, look, I and j look kind of scary, but don't worry. The denominator here says that the asymptote is going to be at x equals 3. So at x equals 3, we're going to put the asymptote. The top tells us that the zeros for the function, the numerator is going to be 0 at x equals -2 and at x equals 1. Those are going to be the two 0 values. Now we need to test values in between. Big positive number is going to give us positive number times positive number divided by negative number, because it's a minus x, so it's going to be negative. Big negative number is going to give us a negative number times negative number in the numerator divided by a positive number in the denominator, which is going to be positive. Between -2 and 1, we have the easy number to test, which is 0. We're going to have 2 times -1, which is -2 on top, divided by 3, which is a negative number. And then between 1 and 3, we could try like number 2. So 2 would be 2 plus 2, which is 4. 2 minus 1, which is 1, and 3 minus 2, which is 1. So that's 3 positive numbers multiplying and dividing times each other, and we get, we get positive there. And that gives us a warm and cozy feeling because we see positive, negative, positive, negative. That's kind of what we see a lot of the times, okay? All right, last problem. Here we got a root at x equals 2, right? And we have a 0 at 0 and 1. So we're going to put 2, 0, and 1 on our number line. 0 and 1 are zeros. 2 is a asymptote. And a big positive number here is going to give us a positive number times a positive number divided by a negative number, which is negative. A big negative number plugged in here is going to give us a negative number times a negative number divided by a positive number, which is positive. Between 1 and 2, let's try like 1.5. Oh, that's going to be kind of a pain. 1.5 times 1.5 minus 1, which is 0.5, divided by 2 minus 1.5, which is 0.5. Those are 3 positive numbers multiplied and divided times each other, so that would be positive, right? Between 0 and 1, we could try 0.5, so that would be 0.5 times negative 0.5 divided by 2 minus 0.5, which is 1.5, so that would be a negative, right? A negative times a positive divided by a positive is a negative. Okay, and so that is the result for J. And this is the result for I. And this is the result for F. Okay. Sorry that was so long.